Good morning, everybody. Good morning, welcome to Austin. Welcome to Pascal Editors Day. I believe this is, if not the largest, one of our largest Editors Day yet. I appreciate you all coming. Had a great event last night. Hopefully you all were able to participate in the launch event and even stick around for entertainment later in the evening. Deadmau5 did a great job. Before we get started, I want to call out a few folks in the audience who are joining us today, just some partners and customers of ours. First of all, we've got a few folks from Micron here, Chris and Marcus. If any of you guys, once you stand up and raise your hand, if you guys want to touch base with them later on, ask any questions, we appreciate them coming. They were a huge part of pulling 1080 together with G5X, so we appreciate them being here. Some of our, also new to Editors Day, we have a few of our system builder partners here, our enthusiast boutique, pushing the edge. Super excited about 1080, and I'm excited about them being here. Kelt, Falcon Northwest, why don't you stand up? Wallace, Main Gear, is Kelt here? Wallace, we see you guys. What's that? They're on the way. All right, well anyway, Main Gear, Origin, Falcon Northwest, and CyberPower. Folks are going to be here later if you want to touch bases with them. So with that, get started on just a quick intro. I wanted to welcome you guys in the event yesterday, our Pascal launch. I think worldwide we got a great deal of coverage from all of you. We really appreciate that. We announced 4 things. At the end of the day, I think we announced 5 initiatives. But Ansel, a photography studio inside your PC. I hope you've all had a chance to demo it. If you haven't, please go in the back, demo it, upload some photos or some 3D bubbles. On the side, you've got images captured by Ansel. We've got a huge mural in the back that was captured by Ansel. We're super excited about what Ansel's going to allow for user-generated content inside of games. VRWorks, we announced positional. It's not really positional audio, I'll call it spatial audio, ray trace bounced audio. We didn't have a demo last night of this. It's the newest addition to VRWorks, but we do have a demo in the back. I think it's in the VR tent. Is that right, Jason? Yes, in the VR tent. If you have an opportunity, this is our first reveal of adding a fully immersive experience inside of VRWorks beyond just visual. But we're adding audio, and there will be new things announced and talked about later in terms of additions to VRWorks. VR Funhouse, check that out. The VR Funhouse demo is going to be our demo that we pack all of our VRWorks technology into. It's right now the physical simulations inside of VR Funhouse are amazing. We're going to put it on Steam ultimately so anybody can enjoy, and we're going to open source it so the community can add to VR Funhouse. We think we're really looking forward to where that's going to go. We announced the new King, some new products, GTX 1080, GTX 1070. Super excited about it. We're going to cover this in a lot more detail later on, the architecture, answer all your questions. Excited about the price point. In terms of performance leap from generation to generation, when you guys get your hands on boards and start testing, I think you're going to be blown away at how much faster we have moved the industry forward, going from Maxwell to Pascal, and you're going to see really the benefits of not just 16 FinFET, but the Pascal architecture. Super excited about that. We also talked about a new way to render. Rendering with a multi-projection, 16-port multi-projection. Jonah's going to go in a lot more detail as displays take different shapes and forms. The rendering of the object needs to take different shapes and forms, not just for efficiency, but also to make sure it's more pixel perfect. So these are the 4 main announcements relative to Pascal at the event last night. There was one more, an initiative that we kicked off called #SaveTom. Our much beloved Tom Peterson is now had his salary doubled. There's a global initiative to make sure that he's loved. I'd like everybody in here to give Tom a hug before you leave, please. That's the Save Tom initiative. Okay, so with that, let me talk about the agenda just briefly. These are the things we're going to cover today. I did the welcome everybody. Thank you for coming. Super excited about the launch and you guys being here. Pascal Architecture, esteemed Jonah Alvin, architect extraordinaire, is going to be up and talking about the Pascal architecture. Of course, he'll be around. We'll all be around during the breaks and afterwards to answer any questions that you guys have. Tom is going to get up and talk about advancements we've made in GPU boost and some SLI. We've also got some new news relative to SLI that he's going to cover. Have a lunch, demos. You guys hopefully will all have a chance to get through the demos. Second, after lunch, Tony Tomasi is going to talk about in more depth about Ansel, the implementation. We've got a couple other surprises for you during his talk. Rev from the Content Tech team is going to talk about VRWorks. Then we'll break the demos. We typically have Editor's Day out. If you're here for Maxwell, it was 2 full days. A lot of information. We're compressing this into about 4.5 hours today. So we're going to try and keep it moving. So with that, I think my job is to get off stage and let Jonah start to talk about the architecture. Yeah?
What can they write about it when?
Oh, sorry, there is one more slide. Damn. You know, this slide scares me. It's like a nuclear warning. But BDR makes me say it. So embargo. The presentations today are embargoed until the 17th. And let me get out of the way so you can all make sure you take a picture of that and remember it. So all information, of course, the information is out last night. Was out last night. I appreciate all the great things you guys said about Pascal and the launch. The information about the architecture and everything else covered today is embargoed until the 17th, 6 a.m. Pacific time. If you have any questions about that, BDR is where you all know BDR or Burke in the back. You can ask them about specific. There's Burke about specific embargoes. Okay. With that, we're going to get into the meat and on to Jonah. Thank you all very much.
Okay, there we go. Got my slides. Cool. This mic's okay? Cool. Great. Okay, cool. Okay, so hi everybody. Thank you for coming here this morning and for joining us last night. I hope you're not too tired from the later night festivities. So I wanted to basically kick off by just going through some of the nuts and bolts of the architecture for you guys. I know that this is something you guys are always interested in hearing about. And so to start, I just wanted to sort of bring up the agenda slide from yesterday. You know, Pascal. You know, this has been a multi-year effort for us. You know, Jensen mentioned yesterday. You know, a very large team working for a long time on a lot of big challenges. You know, what are the next major architectural steps we want to take in the design? You know, the change of 16 FinFET coming in. You know, the biggest change to process technology and transistor architecture in years and years in the semiconductor industry. Sort of making that transition well. Figuring out how to run single-ended signaling faster than has ever been run before, and faster than anybody might have thought was been possible a few years ago, trying to figure that out. And then craftsmanship. You know, I talked about that yesterday. I'll talk about that more today, about just that. That was kind of a theme for the whole team through this process, was just being incredible craftsmen in the work that we do. Just like, you know, if you're a woodworker building a wooden desk and caring about the joints and how everything fits together, that was the mentality, you know, of the whole team in this process. Every part of the team, the architects, the chip designers, the board designers, everyone, and I hope you'll feel that craftsmanship, you know, in the results that your experience with the card. And then, of course, you know, the new technology that Jensen mentioned yesterday, simultaneous multi-projection. So, you know, I wouldn't want to start with things without the classical block diagram, right? So there you go. You can get a picture of that, everybody. So just, you know, before we get into the nuts and bolts, just kind of, you know, hitting the high level, you know, key points of the design. You know, of course, lots of transistors. You know, the clocks. We talked about the clocks yesterday. We'll talk more about the clocks today. You know, we're very proud of the clock speeds that we achieve in this design. 1.61 gigahertz is the base clock, and then 1.73 is the boost clock. And as you saw yesterday, this chip overclocks really nicely. And you know, we'd never seen a GPU above 2 gigahertz before with anything that was less than insane cooling solutions, and this one gets above there. It's really nice to see that. And then, you know, we have the speeds and feeds there, and then the GDDR5X memory, which we'll talk about more, which is, you know, the next generation memory, you know, the first new memory architecture basically in 7 years since we had the G5 come out in 2009. Okay, so first, you know, I talked about craftsmanship. You know, I want to sort of bring up one of the areas of craftsmanship which the team was very focused on there, which is craftsmanship related to speed. This for the chip designers, board designers is acoustics, regulator efficiency. Jensen talked about that yesterday. Every generation we're learning more about how to be better at our craft and raising the bar there. For the chip designers, speed is really one of the key elements of craftsmanship, right? If you could have a design that's built very well overall, but you just have one path that's slow, and that slow path will set the speed of the entire chip. So you have to have the whole team have the right mentality and all working together to really tune that design up. And it's a bigger challenge going to a new process node like 16 FinFET, because the properties of all your paths kind of change around, right? So if you just take an old design and flip it over, the work you did last time that made things work out well might not actually make things work out well this time. So you really got to come into it as this is a new challenge and just be ready to face that challenge. And going into 16 FinFET and being scientists, understanding what the process was about, understanding what it was looking for in terms of paths, and designing the chip for 16 FinFET was a big focus for the team. And just to explain this picture here, so I just took a snapshot. This is one of the parts of the chip. We look at charts like this all the time, but basically what you're seeing is on the bottom axis is the speed the chip would be running at for that given path, and then the y-axis is the number of paths that are slower than that speed. Right. So, for example, if I take the dark green, which is kind of an earlier part of the process, right, the slowest path would have given us a 1325 megahertz boost clock, which obviously wouldn't have been as exciting, right? And then as you go along, you get kind of 10, 20, 30, 40, 50 paths that violate that, and then at some point it really starts shooting up. You get thousands of paths that at this point kind of 1600, 1650-ish or whatever is kind of what we would have been able to do with those thousands of paths, right? So that, but that's where you get in and you do more work, right? So we really worked hard on this. We learned a lot from past generation, and I think we're really happy with the results in the end. So you see here, basically, we figured out what was going on with those paths down there. We cleaned those up. We were able to make all the paths a lot faster, just the team just working to get that timing to be really nice. And then what you see in the end is kind of what you'd want to see, which is basically a pretty sharp slope up, right? You don't want to see one or two paths or 100 paths sticking out. You kind of want to see that, this basically, if you wanted to push any further, it would have cost you like 800 years or whatever, right? And then you sort of say, well, then I guess I'm done. I got what I could out of the design. So we're really proud of the frequency of the chip, and this is really what it came from. It's basically just a lot of knowing the technology, and then a lot of hard work by the team to really try to make sure the design was done well. We didn't just throw a whole bunch of flops in the design and brute force it, right? It was more about just taking the design and taking these paths and really crafting them well, taking the ones that needed some timing help and doing that design work to do that to get the good speed results we have.